This is the EdPuzzle quiz for Unit 1, Section 4 on density. So what is density? Well, density is a measurement of how much stuff there is within a given space. For instance, if I have a dumbbell, that has a lot of stuff in a relatively small space. We'd say that a dumbbell has high density. If we look at something like this styrofoam cooler, it doesn't have a lot of stuff, but it's a little bit bigger. And we'd say that styrofoam has a low density. Something like a hot air balloon, that's also not a lot of stuff. It's relatively light, but it's a very large space. A hot air balloon would also have a low density. So, in density, when we talk about stuff and space, the stuff is really the mass. And this is the amount and type of atoms in a substance. How many atoms there are in that substance will correlate to how much mass there is. The more atoms, the more mass. We usually measure mass with a scale, as seen on the right here, and we use the unit grams, abbreviated with this small g, this lowercase g. Space, however, is volume, and this is basically how big an object is. We will usually measure this with a ruler or with a technique called water displacement, which we'll get into in a little bit. And volume has the units of milliliters, abbreviated as lowercase m, capital L. As an example, before sponges are shipped to be sold in stores, they are huge blocks. We can see this huge pink block of sponge in the image. These are very large, but also very light. Think it's a sponge, because they don't have much stuff in them. Would this sponge block have a large high density, or a small or low density? Another example, gold bars, if you see them in a movie, like a heist movie, they're surprisingly heavy. The bar in this woman's hand is a few pounds, even though it's relatively small. Would this gold bar have a large and high density, or a small and low density? Next, we have a rock and we want to know its density. So you take a few measurements. First off, we want to find density, so what information will we need? Select everything that is true. Next, you place the rock on a scale, and the scale reads 346 grams, or it might say 346 with a lowercase g. What is this a measurement of, this 346 grams? And finally, you use water displacement method to find out that the object takes up 106 milliliters of space. You basically drop it in this graduated cylinder. When we find that 106 milliliters of space, what is this a measurement of? Now let's actually talk about how to calculate density. There is one main equation we use, and that is that density equals mass divided by volume. And we shorten that a lot of times to D equals m over v. We will use this equation if we want to find density, but we know the mass and the volume of an object. Now let's take a look at an example. Let's say that we measure the mass of an object and it's 65.1 grams, and we measure the volume as 125 milliliters. If we want to know its density, we'll use that equation, density equals mass divided by volume. We'll plug in the mass in the numerator, 65.1 grams, and the volume in the denominator, 125 milliliters. And we will then divide those to get the density. 65.1 divided by 125 gives us 0.5208, and the units of density are grams per milliliter. There are two other equations we might use. One equation is seen on the left here, and that is that volume equals mass divided by density, or V equals m over d. We use this equation if we want to find volume, but we know density and mass. And our other equation is mass equals density times volume, or m equals v times d. And we use this equation if we want to find the mass of an object, but we know its density and volume. For an example, if we know that an object has a mass of 22.5 grams and a density of 3.2 grams per milliliter, and we want to know its volume, we'll use the equation volume equals mass divided by density because we want to find volume. We'll plug in the mass in the numerator, 22.5 grams, and the density in the denominator, 3.2 grams per milliliter. We'll do 22.5 divided by 3.2, and we'll find the volume is 7.03 in milliliters because it's volume. In our last example, we know the volume of the object is 45 milliliters, and its density is 1.6 grams per milliliter. Because we want to know what its mass is, we'll use mass equals volume times density. We'll plug in the volume, 45 milliliters, times the density, 1.67 grams per milliliter, and then we'll multiply 75.15 grams as its mass. So a few quick examples. In the previous example, we had a rock with a mass of 346 grams and a volume of 106 milliliters, and we want to know what is the density of this rock. Here are the three equations below. Go ahead and calculate the density. In our next example, the gold bar has a mass of 1,000 grams. Gold has a density of 19.3 grams per milliliter. What is the volume of this gold bar? Again, here are the three equations. Go ahead and try to calculate volume. And in our last example, this rubber duck weighs 25 grams and takes up about 50 milliliters of space, and we want to find the density of this rubber duck. Go ahead and use these three equations. There is actually one more example. We have a large metal sculpture of Bigfoot. It is made of iron, and it has a density of 7.87 grams per milliliter. This sculpture takes up around 175,000 milliliters of space. What is the mass of this sculpture? Use one of the three equations below to find out the mass of that sculpture. Now, sometimes volume can be difficult to measure, but we have a technique that makes it easy to measure volume. We call that water displacement. In water displacement, we will take a graduated cylinder and we'll put an initial level of water into that graduated cylinder. For example, we might measure out 30 milliliters of water into our graduated cylinder to start. We'll then place an object in the water, and the final water level will rise because the object pushes it up. And as an example, we might see the water level rise to 40 milliliters after we place our object in. The object's volume is equal to the difference in these two numbers. So it's the final level minus the initial. In this case, 40 minus 30 gets us to 10 milliliters for our object. We can use that volume in a density calculation. And here's an example of that. You want to know the density of a key. So you place it on a scale and it reads 15.2 grams. You then measure out 25 milliliters of water into a graduated cylinder. After you drop the key in the water level rises to 34 milliliters. But we want to know the density of that key. Here are three equations that can help you out. Go ahead and try to calculate density of that key. And that is it for the Unit 1, Section 4 EdPuzzle quiz on density.